There are two ways to multiply fractions. The first way is fairly straightforward, where we literally multiply the two numbers in the numerator and the two numbers in the denominators together. So if we were to do it that way, 8 times 7 would give us 56, and 5 times 10 would give us 50. The problem with doing it this way is that we often have to simplify this final result. So we have to simplify the fraction 56 over 50. If we go ahead and do that, we need to figure out what number divides into both of these values. And I know that they're even numbers. One of them ends with a 6, one of them ends with a 0. So when we have even numbers, we can try dividing them by 2 as a starting point. So if I divide them by 2 to simplify the fraction, we end up getting a 28 in the numerator and a 25 in the denominator. After we do the division, we're left with 28 over 25, which we cannot simplify any further. So that would be our answer. So when we multiply fractions, we're always allowed to do that. We can literally multiply all the numerators together and multiply all of the denominators together and simplify the result. This video is not going to focus on that method simply because you're going to come across a lot of problems where you're going to have multiple fractions, and this is not going to be the best approach to solve those problems. So I'm going to erase what we just did, and I'm going to explain an alternate way of multiplying fractions. So we have a fraction, and what I want to do is I want to look at the diagonals. I want to look at a number that's on top for one of the fractions and a number that's at the bottom of the other fraction. In this case, we have an 8 and a 10. We also have a 5 and a 7, but I'm going to ignore those for now. We have an 8 and a 10. We can think of it as 8 over 10 as a fraction. If we simplify this fraction, what number goes into 8 and 10? That would be the number 2. So we can divide both of these by 2. This would leave us with a fraction of 4 over 5. So what I'm allowed to do is, instead of keeping this fraction as having an 8 on top and a 10 at the bottom, we're going to replace the 8 with this 4, and we're going to replace this 10 with a 5. So now what we do is we look at the other diagonals. We look at the 5 and the 7. And if we think about 7 over 5 as a fraction, this cannot be simplified. There's no number that goes into 7 and into 5. So we leave it alone as a 7 and a 5. But now what we're left with is these two numbers in the numerator, a 4 and a 7. So if we multiply 4 times 7, we're left with 28. If we multiply the denominators, the 5 times 5, we end up with the 25. Because we had already simplified this expression to begin with, most of the time our final answer is going to be as simplified as it can get. And that's the case for this problem. So we don't need to do any more simplification with large numbers. Instead, we're left with our final answer here. So we're going to carry on this idea of simplifying the diagonals for the remaining problems. For this problem, we can approach it the lazy way by just multiplying left and right. The problem with this is that we're left with really large numbers, which we can work with if we really wanted to. We can do 4 times 15, and that would give us 60. But then we'd be left with these large numbers, and 3 times 14 would give us 30, 42. And you would have to simplify 60 over 42 if you did it that way. So what I want to do instead is I want to simplify these fractions before I do any multiplication. So I'm going to look at the diagonals. I'm going to look at 4 and 14, and then I'm going to look at 3 and 15. So one at a time, I'm looking at 4 and 14. In our heads, we can pretend like it's written down like this, and we're simplifying this fraction here. What number goes into both 4 and 14? Well, that number would be a 2. So if we divide both of those by 2, we're left with a 2 over 7. So what I'm going to do is, in our original expression, I'm going to replace this 4 with a 2, and I'm going to replace this 14 with a 7. Now I'm going to repeat the process for the other diagonal, the 15 and the 3. So if I write the 15 and the 3 off to the side, I want to simplify this fraction. What number goes into both 15 and 3? That would be the number 3. So we can divide both the top and the bottom by the number 3, and 15 divided by 3 is 5. 3 divided by 3 is 1. So we're going to replace the 15 with a 5 and a 3 with a 1. So hopefully this isn't too difficult to read, but what we have at this point in the problem is we have 2 over 1 times 5 over 7. At this point we can go ahead and multiply left and right. 2 times 5 gives us 10, 1 times 7 gives us 7. And we don't need to worry about simplifying this. It's as simplified as it's going to get. So in using this method and simplifying the numbers that are diagonal to each other, it makes it a lot easier to do the actual multiplication in our head without using a calculator. For this problem, we have 3 sets of fractions. We can approach it the lazy way by just multiplying the numerators together and the denominators together. But instead of doing it that way, let's say that I want to look at my diagonals and I want to simplify the numbers that way. The way it works is you can mix and match whichever number on this numerator, whatever top number you want, with whatever bottom number that you want. So we can do 3 and 5, but the problem is you cannot simplify 3 over 5. You can try 4 and 5, but you cannot simplify those two either. Instead, the numbers that we really want to choose is 5 and 5. So they're kind of far away from each other visually, but they are diagonal. So we can simplify 5 over 5. 5 over 5 would give us 1 over 1. So what I'm going to do is I'm literally going to take these 5s and replace both of them with a 1. If I go through the other numbers or the other combinations of diagonals, we can look at 1 and 4, but they don't simplify. We can also look at 3 and 7, but they also cannot be simplified. So at this point, we're done with the simplifications. Now we just need to multiply the numbers together. So we're going to multiply all the numerators together and all of the denominators together. In the numerator, 1 times 3 times another 1 is 3. For our denominators, we have 1 times 4 times 7 gives us 28. Because we had already simplified these numbers, we know that this fraction cannot be simplified any further, and we're done with the problem. This problem has 3 sets of fractions. We're going to do what we've been doing and look at the diagonals of these fractions to see if we can simplify any combination of numbers. If we look at 3 and 1, that cannot be simplified. 11 over 3, or 3 over 11 cannot be simplified. 2 and 11 cannot be simplified. And 1 and 5 also cannot be simplified. But if we look at these numbers up here, this 3 and these 3 over 3 can be simplified. So that's what I want to do, is I want to simplify this fraction, 3 over 3. We can divide the 3 and the 3 by another 3, because 3 divided by 3 would give us 1, and 3 divided by 3 would give us 1. So we end up simplifying these 3's into 1's. So now in our numerator, if we go ahead and multiply it out, we have 2 times 1 times 1, which is just 2. In my denominator, I have 1 times 11 times 5. 1 times 11 is 11, times 5 is 55. And our answer is already simplified, so we're done with the problem. For this problem, we also have 3 sets of numbers, except one of them is not a fraction, it's just a whole number. Anytime we have this situation where we're multiplying fractions together, and you have this whole number by itself, we want to turn that whole number into a fraction to make the problem easier to work with. To turn any number into a fraction, we can put it over 1. One way to think about it is 10 divided by 1 is equal to 10. It keeps its identity, it keeps the original value. But now we're going to think of it as a fraction of 10 over 1. So if I just rewrite these fractions off to the side to make it a little easier to visualize, this is what we have so far. Now I can approach this problem the lazy way by multiplying numbers left to right. But the problem with that is we end up getting this 17 times 5, which is possible to multiply, but it's just too large of a number to deal with. So instead, I want to look at the diagonals and see if we can simplify any of the numbers. I always start with this diagonal, but in this case, we cannot simplify 2 and 17. Then I move on to this one, and in this case we can simplify 10 over 5. If we imagine that it's a 10 over 5, what number fits into both 10 and 5? That would be 5. So we can divide both numbers by 5. 10 divided by 5 gives me 2. 5 divided by 5 gives me 1. So in this problem, we can replace this 10 with a 2, and we can replace this 5 with a 1. So it'll look like this. Now that those two numbers are simplified, we can look at the rest of our diagonals to see if we can simplify them. So we already looked at these two sets, and we can't simplify them any further. Now if I look in the other direction, the other diagonals, we have a 2 and a 1 and a 2 and a 1. Those also cannot be simplified. Oh, and I guess the last set of numbers is the 2 and the 17, which cannot be simplified. So now that we can't simplify them any further, we can go ahead and do the multiplication. In the numerator, 2 times 2 gives us 4, times another 2 gives us 8. And for our denominator, we have 17 times 1 times 1. That'll give us 17. And 8 over 17 would be our final answer. So hopefully you found this method of multiplying fractions useful. It's not as simple as the lazy way of just multiplying the numerators and denominators, but for a lot of the problems that you'll come across that deal with fractions, it'll make it a lot easier to work through without using a calculator.